We are starting now the topic of kinematic for M1. The question is, a particle P is projected vertically upward with a speed of 5 meters per second from a point A, which is 2.8 meter above the ground, horizontal ground. Part A, find the greatest height above the ground reached by the particle P and find the length of the time for which P is at a height of more than 3.6 meters from the ground. So, if we draw the figure of this question, this is the point O there, and that is the point A, which is 2.8 meter above the ground. Since it is being projected from this point A above vertically, so at the point B, its final velocity will be equal to 0, whereas initial speed at this point is 5 meters per second. Since this particle is moving under the influence of gravity, so we can use the equation of motions for this part as equal to, let's say, the height above this ground is h1 and this is already 2.8 meters. So we can use the equation of motions as 2gs is equal to v square minus u square. So 2 as this, g is minus 10 because it is moving upward, and s1 is the height h1, and that is equal to 0 square minus 5 square. So this minus 20, h1 is equal to minus 25, minus and minus cancel out. So h1 is equal to 25 over 20, and that thing is equal to 1.25 meters. So total height of this particle P above the ground is 2.8 plus this height h1. So that thing is equal to 2.8 plus 1.25. So that thing is equal to 4.05 meter above the ground of this part. In the second part of this question, they ask that find the total time taken by the particle P when it is at a height of more than 3.6 meter from the ground. So when we draw the figure again, here u is equal to 5 meters per second. Let's say that is O, let's say that is A, and let's say that is B, and that is, let's say, at a height of 3.6 meter above the ground. So we have to take a time from this position P to this Q there. The difference of this Q and E times there will be the total height of this particle above the ground when it is 3.6 meter there. So U is 5 meters per second. We don't know the value of velocity at the particle P, but we can use another equation of motions there, that S is equal to ut plus half gt square. But for this S is there because it is 3.6 meter and this one is 2.8 meter. So S is equal to 3.6 minus 2.8 and that is equal to 0.8 meters. So we can find out the times now that S is equal to 0.8 is equal to U is 5t plus half into minus 10 into t squared. So this will become 0.8 is equal to 5t minus 5t squared. Or this will become 5t squared minus 5t plus 0.8 equal to 0. This is a quadratic equation and we can apply it here, the quadratic formula. So you will get 2 times here. So that is equal to 5 plus minus 25 minus 4 into 5 into 0.8 over 2 into 5. And the two times of this particle will be equal to 0.2 seconds and 0.8 seconds. So up till A to E it is 0.2 seconds and up till this point it is 0.8 seconds. So the total time difference between these two portions is 0.8 minus 0.2 and that is equal to 0.6 seconds when this particle is more than 3.6 meter above the ground. The calculation for this question number 1 of this topic of kinematic that we have solved completely on this board for you.